Okay, so lessons 5 and 6, what we're doing on Tuesday, are going to be really big. Turns out there's not a whole lot of abstractions or complicated things we're going to talk about, but there's just a ton of simple things we're going to talk about. So we start with lesson 5, which probably seems a bit simple, and then lesson 6, in my opinion, may be a little overloaded. So again, it's all simple stuff, but there's just a ton of things we got to worry about. So what we're going to talk about in lesson 5 is nomenclature of alkanes. Okay, so I want you to be thinking about alkanes. Watch the similarity here, and alkyl. All right. So an alkane is a sort of the main thing we're talking about, and alkyls are substituents. Alright, so an alkane, for example, would be methane. An alkyl would be methyl, right? So look at that. Ane, eel. Okay, and so methane looks like this, and a methyl group is if you've got, one of the hydrogens taken off, and that is sort of the substituent. That's placed on your parent molecule. Okay? So the alkanes are methane, ethane, propane, butane, hexane, heptane, and so on. And these are listed at the beginning of chapter 3, so I'd like you to look at those. I think we're going to go up to decane. We don't need to know anything beyond that, so just skip octane and nonane. What's the substituent? If ethane is a substituent on the side of something else, what's it called? Ethyl, right? If propane is, we get rid of the ane and we put prop-il. Okay? So, with this in the background, in the back of your mind, you will want to look at table 3.2. Table 3.2 is a big one. And table 3.1. Tables 3.1 and 3.2 really have all this information in it. Alright? So now let's talk about how we're going to name simple straight chain alkanes. 1, 2, 3, 4, 5. Well, I just did, I guess, right? 1, 2, 3, 4, 5. That makes that. Oops, I skipped pentane. Did anybody notice that? Okay, butane. Pentane is 5. Hexane is 6. Heptane is 7. Okay, so that's pentane. Now, if that's pentane, what is this? Here's the question. I'm not going to tell you. I'm not going to tell you the answer. You tell me. If that's pentane, what is this? Boom, 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 boom. What is that? That's the question of the hour. All right? And then, if you know what the answer to that is, I'm going to ask you in class, why is that a decent question? And why do some students who are paying attention and doing their homework and trying struggle with this? What's the challenge between these two? Okay, so that's the first section that we're going to do. The next section that is simple straight chain alkanes. The next section we're going to do is branched, and that's where we need both of these guys. We need both alkanes and alkyl if we've got something branched. So 1, 2, 3, 4 is the smallest. No, that's not the smallest branched that we can have, but there's a branched. Okay, so when we're doing branched, here's what we're going to do, and this is where I introduce the rules for nomenclature, and they're always going to sound the same. Rule number 1. Identify the longest continuous carbon chain, and I'm going to put with the principal functional group in it, okay? Which that'll make more sense in lesson 6. With the principal functional group in it. There's no functional groups here, but we're always going to say find the longest continuous carbon chain with the principal functional group in it. That's step 1. So it looks like if I go here, I have 1, 2, 3, 4, and that would be butane. I myself am probably going to circle it and then name the thing that's circled. Then I'm going to go through and identify. Number 2, ID all substituents. Okay, and so my substituent here is methyl. Okay, and then number 4 is address all substituents. It's a slightly different version than what you have in your book, okay? It's equivalent, of course. Address all substituents. So in other words, this is either 1, 2, 3, 4, or 1, 2, 3, 4. Those are the possible numbering for this this parent chain. It's either 1, 2. It's either 2, 1, 2, 3. It's either 2 or 3. Which is it? And it gets the lowest number, of course. So it's 2-methyl. And then finally, we tape everything together. Get yourself a big roll of, I don't know, duct tape will work nicely. You cut these things out, and you tape them together, and you're going to have to tape them together alphabetically. Now, this is so obvious you might be tempted just to jump from here to the answer on your quiz or exam, but I do recommend that you write these out, write them out just like I'm writing them, in all simple steps, and you'll be less likely to make a mistake under pressure. 2-methyl butane. That's it. Okay? Now what if you have 2 substituents? If you've got 2 substituents, let's go. 1, 2, 3, 4, 5. Okay, there's a substituent, and there's a substituent. Alright, so you may be tempted to say, alright, let's find the longest continuous carbon chain with the principal functional group in it. Boom. And somebody else is going to come along and go, no, that's not it. The longest continuous carbon chain with the principal functional group in it is here. How do I know? Well, I counted them, okay? So, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. So 7 is the one, right? The longest continuous carbon chain with the principal functional group in it is heptane. Now I'm going to go through and circle everything that's not inside there and name it. There's something that wasn't inside, it's a methyl. There's another methyl, and here's another methyl, okay? So it's tri-methyl heptane, and I'm going to have to name where these guys are. So I can see that everything's closer to this end, so I'm going to start here. 1, 2, 3, 4, 5, 6, 7. So it looks like I've got a methyl on the 2, one on the 3, and one on the 4. So it's 2, 3, 4. Trimethyl. Finally, tape everything together. Trimethyl heptane. Okay? And then the final issue in lesson 5 is cycloalkanes. And I don't know if you need me to tell you this or not, but I'm going to tell you. I think this is section 3.3. And that would be cyclopropane, of course, cyclobutane, cyclopentane, cyclohexane. Okay? And the final point I think that's made with respect to these is if you've got that and you've got, we'll see, 1, 2, 3, 4, 5. Now all of a sudden finding the longest continuous carbon chain with the principal functional group in it becomes a little bit, I don't know, slippery, right? Because you might argue 1, 2, 3, 4, 5 carbons in the longest carbon chain, but that one's still kind of in the longest carbon chain, right? And then he has 2, and he has 2, and he has 2. But it becomes obviously a little bit tricky if we include that. So what we're going to do is we're going to say that's not in the longest or that's not in the same chain as this over here. This has 1, 2, 3, 4, 5 that only has 3 in it. So if that's the case, this is the longest continuous carbon chain, and we're going to call that the substituent. The longest continuous carbon chain is pentane, and the substituent is cycloprop. What would have been propane is now propyl, right? Because we went from alkane to alkyl, because it's a substituent now, so it's cyclopropyl pentane. And we have to say where it is. 1, 2, 3, I can see it's closer to this end. It's actually on the 1 carbon. So it's 1 cyclopropyl pentane. Okay, and that's lesson 5.